Hi, welcome to OffSecOps. My name is Will Schroeder. My handle is Harmjoy on Twitter and GitHub. I'm a technical architect here at SpecterOps. I've written a lot of code over the past several years, most of it offensive in nature. I was one of the primary developers of the Veil framework, as well as the Empire project. I wrote the PowerView and PowerUp toolsets, was a co-founder for the Bloodhound project, and the primary author on the GhostPack C# exploitation, post-exploitation type tool set, including things like SharpDP API, Rubius, Seatbelt, and more. I've talked at a lot of conferences over the past several years, everything from DerbyCon to Troopers, and I am a veteran trainer. So I'm the principal architect for our Adversary Tactics Red Team Operations course. I was a developer on the Offensive PowerShell course that we retired last year, and I sometimes blog at blog.harmjoy.net. So TLDR, what we're going to cover today. Essentially, this whole presentation is about why you should consider integrating DevOps practices into your OffSec pipelines or offensive security operations. I'm going to cover previous work, a lot of it from Adam Chester, XPN, as well as other people at MDSec. Then I'm going to touch on our architecture, specifically declarative Jenkins pipelines, including structure, how we build them, how we store them, common library functions of files, parameter pass-throughs, and meta jobs. Also Artifactory, so artifact storage, Cobalt Strike integration, artifact tracking, all these types of fun things. And then how we can actually apply this architecture to do interesting things. So things like proactive checksum scanning to see if any of your artifacts leaked. Do OPSEC checks on any artifacts before you actually deploy these artifacts to real customer environments. Artifact fingerprinting to get custom IOCs from things. Or proactive stamping out of known IOCs from public tool sets for source code repos that you don't actually control. Lots of cool things that we'll touch on. So why OffSec needs DevOps? And with DevOps, I'm generally talking about this process that's come up over the last 10 years for software engineering, of that kind of plan, code, build, test, release, deploy, operate, monitor type classic cycle that feeds into each other. Where essentially this is a process and a series of practices that try to facilitate the rapid deployment of code through software engineering. So there's no reason this can't apply to offensive security as well. So this tweet from Adam, XPN, is saying, this is your monthly reminder that with offensive security, DevOps is your friend. So this is a screenshot of some Azure DevOps pipelines for building things like Rubius, SharpDump, Seatbelt, and others. And we're going to get into why some of the things matter and why they can be an advantage to you. Because offset code, offensive code, is just like any other code. It needs proper testing, version control, validation, all that kind of fun stuff. But there's also some special considerations for offensive focused tool sets. Specifically, things like obfuscation, whether it's C#, C, and C++, so some C-lang stuff, PowerShell, obfuscation with evoke obfuscation, or comment stripping, any of those types of things. Then also things like indicator stripping. Like I had mentioned, there might be known IOCs or indicators for public tool sets, or if you don't want to keep a private branch, maybe you can just patch out those known IOCs or change them up on build. We also care about per-op tracking of artifacts, which we'll get into why that matters and how you can actually do this. Also vetting, like how much do you actually trust all this offensive tool authors, right? Have you read through any of the code, or how do you control updates? Someone pushes an update to a new tool set, does that just get deployed off in your builds and all those types of things? And we'll cover ways to kind of try to mitigate some of these concerns. But also an idea here is that if you build this process, you're able to kind of transparently insert yourself into an engagement critical process and standardize your tool set across all engagements. So if you want to update something like obfuscation or IOC collection or whatever else, you're already hooked into all these things, then you're able to update those little bits without interrupting the normal flow of operations or with operators even knowing. So there's definitely some previous work here. A lot of it is from XPN, Domchel, and some other people at MDSec for all this kind of specifically normally like Azure DevOps type stuff. There's a little bit from ReverseShell as well, and there's a bit of Jenkins stuff from Chris Trunser. I'm sure there's plenty more that I've missed. I just tried to do my best to kind of pull up some of these references. So you might be thinking, like, why are you reinventing the wheel? Why not just reuse some of the existing Azure DevOps approaches that are already out there and already been published? The short answer is that we don't trust organizations to not collect telemetry in our offensive tools and or operations. Our general philosophy tends to be we want to host as much of our offensive infrastructure, including DevOps pipelines, on hardware that we own and control. We're not saying that using Azure DevOps is wrong. We're not saying that it doesn't have advantages over this approach, which it definitely does. It's just a philosophical reason that we took this approach is saying we want to control everything as much as we can within reason. We started from that point and then built the architecture from there. So this is what we came up with. We have on the top left there, we're going to have Git, used to be Bitbucket, now moving to GitLab. This is where we store all of our build pipelines and everything as code. We have the Jenkins kind of master build server along with the master Jenkins control server, along with the Jenkins build servers or different OSs underneath. Our SpecterOps VMs have different ways to interface in that will trigger jobs to build all our specific tools. Those artifacts are stored in Artifactory, which are retrieved from VMs as well. This is all kind of our VPN enclave, those types of things. We also have connections into Slack for monitoring stuff about artifacts presented, things that got leaked and all that, so we can do alerts. We have ways that we need to actually pull down public repositories into the different Jenkins build servers. And we have some API hash check stuff, which we'll touch on in a bit. Another great thing is everything here is free. So the hardware isn't free, but all the software you can do for free with free versions of GitLab. Jenkins is open source, is free. There's a free version of Artifactory. You can do free Slack instances and hooks and all that kind of stuff in. GitHub allows free hosting. So there are ways that you can pay and get different products for this, but the way that we architected this didn't make it do exactly kind of what we wanted. We actually ended up just going with all these kind of free or open source solutions. So Declarative Jenkins, what the heck does that mean? Jenkins jobs are essentially like the instances that tell a Jenkins server how to build a project. They come in a few different flavors. Some people are familiar with the classic or freestyle jobs, which are just kind of stored in the Jenkins server itself through the GUI. The more modern way to do these jobs are through scripted or kind of version 2 of that are declarative pipelines. So what does this mean? These are essentially just pipelines as code through a specific language. And they allow you to construct your Jenkins builds properly as code that you can then store on some kind of SCM, for us, internal GitLab, into a single or multiple repos. You can also define and use common library functions through Jenkins, through Declarative Jenkins, which we'll talk about here in a second. So what this repo actually looks like, we just have a single offensive toolset repo. Underneath, it's broken out by language and then by project. And under each project, there's a single Jenkins file that is then cloned down from the Jenkins declarative pipeline. So this lets us update and check and kind of track everything very, very easily in a central place. The language in declarative Jenkins files is groovy. It's a little bit weird. It can be a little bit annoying at times, but in general, it's not too bad. It's like code is code. It's not that different from other things. You have different steps and stages and things you can do with this. You see some of the code here, like obfuscating binaries or building them or testing the OPSEC. This is just kind of an example to give you an idea of what it looks like. At the end of this presentation, I have a POC or GTFO sample for kind of a declarative pipeline that we tend to use. Like I mentioned, one nice thing with Jenkins declarative pipeline files is they allow the use of library functions. So these reside in a single second internal GitLab repo, and they're cloned down and compiled for any project that references the library name. So this lets us centralize common functionality and update it across all builds. So let's say that you wanted to change the way you were doing obfuscation across all the builds, and you had a common function built for that. Instead of having to go into dozens or 50 plus different declarative pipelines and changing different options or the method or whatever else, we can change it in the single common library repo function, and that's automatically pushed down to all the builds without us doing anything else. Also, obviously things like script comment stripping for like PowerShell, artifact fingerprint extraction like we mentioned before, SRDI conversion, basically anything that we want to do more than once in any kind of repo for the offensive build pipeline stuff will tend to pull out to a common library function. This is one thing that Jenkins does really nicely versus some of the other approaches, I think, personal opinion. Also, I mentioned like kind of this parameter pass-through stuff at the beginning. So declarative Jenkins jobs can take build parameters. Most CI pipeline stuff can take build parameters. So imagine just like a string that says, op ID equals X or something. And Jenkins jobs can kick off other Jenkins jobs, and they can also pass through their parameters. So this allows us to basically construct a meta build that says offensive toolset, where it takes an op ID or engagement ID parameter, And this will kick off all the other offensive toolset jobs and pass that parameter through. So it filters down to individual tool builds. We also insert a little bit of benign randomness into each tool. Imagine you like random GUIs or strings dependent or tweak just a little bit. So we can ensure the uniqueness of every single build of every single individual artifact. So the TLDR translation of all this is that we can produce, for every engagement, a complete build of the entire offensive toolset in a way that each build artifact is unique for every engagement. So given a particular checksum, SHA-1 or MD5, of any artifact we've ever deployed, we can track that back to the exact tool name and op ID that we actually have, that it came from. This is just an example of kind of a meta build, so where you're passing through some of these project IDs, nothing too crazy. And that's the build side with Jenkins. Now, what do we do with these artifacts after they're built? We use Artifactory. So this functions as the central artifact repository for all of our offensive artifacts and IOCs. So Artifactory is a binary repository, which is kind of a natural extension to a source code repo, in that it will store the outcome of build processes or artifacts. So any PowerShell PS1, any position-independent shellcode blob bin, any C# built assembly gets stored in Artifactory after it's generated on the Jenkins side. That project ID or engagement ID that I mentioned, that metadata, is passed through this build job and is used to tag and structure the resulting project folder in Artifactory, which I'll give an example here in a sec. There's also the Artifactory query language, AQL, and the Artifactory API, which is very well documented and fleshed out. So you can use this to query and search for specific artifacts like per engagement or artifacts with certain characteristics. So combining this, there is a really nice interface and interplay between Jenkins and Artifactory. There's really nice plugins for it, makes it super easy. You just specify the exact built artifact in the folder that you want to deploy to Artifactory in the Artifactory instance, where you want to deploy it to, and you can add custom properties or metadata to it as well, with things like project ID or language or purpose of the artifact or something like that. This is what it'll tend to look like, or how we have it structured. We have our offensive toolkit folder. We have projects broken out with each different project ID, and we have all the actual artifacts that are built underneath. So we have all the EXEs, everything else, and we have metadata over on the right, and you can download as you want. And how do operators actually download this stuff? We adapted MDSec's execute GitHub assembly aggressor to pull artifacts from the local Artifactory instance for the specified engagement ID for the op. So this allows operators to easily pull down any C# position-independent shellcode or PowerShell payload through like the native Beacon Cobalt Strike interface. And once you load up the toolkit, you have that project or op ID that's synced with the main control server. Then everything you're pulling down is going to automatically pull down just for your particular built project ID. We also have manual PowerShell and Python scripts that interact with the Jenkins API. API in air quotes because it is not a great API, but you can still use it to trigger jobs, and pulling down artifacts from the Artifactory API is way, way nicer. So this is kind of how we built everything in. So the end result will be something like this, where you have different functions. For example, execute Jenkins assembly. You give the assembly name, that has the version kind of in the name there, that will automatically pull down the appropriately tagged assembly from the Artifactory server built from Jenkins, put into Artifactory, downloaded to the engagement VM, to the temp folder, and then deploy through Beacon with execute assembly. Pretty seamless. Okay, now that we have our offensive toolkit defined as code, what can we do with this architecture? So it's obviously really nice to have just a built and kind of standardized tool set across all your engagements, but that's just the first step. There's a lot more interesting things you can do with this now that you've kind of put yourself right into this, part of the pipeline between your operators and everything being built. So, submitted artifact detection. Remember that each artifact we're building is unique per engagement. Every single time every project is built, the resulting artifact will be unique from a checksum or hash standpoint. We also have that engagement ID that's being passed through as metadata from the Jenkins meta build to the Jenkins project build, passed through when it's actually registering the artifact in Artifactory. But why don't we build another Jenkins declarative pipeline that periodically pulls all the checksums for all artifacts, say for the past 2 months from Artifactory, And then scans, a theoretical like online submission service to see if any artifact or checksums from recent engagements had been submitted to said online service. And if anything does match, we can alert Slack with the tool name and engagement ID of something that was leaked. Say by a blue teamer that decides to submit something up. This is what this theoretical bot might kind of look like, to where you're saying, okay, from this particular op ID, this tool with this hash scanned at this particular point was submitted by somebody to, some kind of online service. Just saying, it's just, an interesting idea. Also, this is one of my favorites, indicator stripping. So if any tools that we're using, like public tools, have any known indicators of compromise or like dirty terms. So say, some project had harm joy in the source code or something like that when it builds, and say that code is public and you don't have control of it. Your main options would be either to maintain an internal branch, which can get difficult if the project is being updated periodically, or you can do that type of processing, pre-build processing on that build side. So when you clone the project down, why not just have a function that replaces out like known bad words? Or known words that might flag AV, like obscuresec or harmjoy or mimikatz or gentle kiwi. Or something that replaces, C# assembly info CSs, those known kind of little metadata bits with like clean ones or randomized ones. Just along this kind of line too, as another kind of sanity check for us, we have another repo. That's a common repo. Again, all is code, all put into GitLab, that has a series of OPSEC checks. These are constructed through Pester. It's like a set of PowerShell tests. And we'll do things like checking .NET versions, whether PDB strings or debug stuff is actually present or not, but also all the strings in the binary for like dirty handles, author names, project names, harmjoy, and obscuresec, and whatever else. Because we're hooked into this whole kind of process, we can proactively scan every tool build for simple OPSEC failures. And the way we have this built, and the way you can do it through Jenkins, is that if any of these tests fail, then the built artifact will not be put into Artifactory. So this essentially ensures that as long as people are pulling artifacts from the final Artifactory instance, there's no way for any of those artifacts to get through that accidentally have any of these known kind of bad IOCs in them. This is one of my favorite applications of having everything centralized in this process. You can also do your own custom fingerprinting of all the artifacts that are generated. So we have a series of IOC type collections that we pull from our artifacts. So we store that IOCs file for every single artifact that's ever been deployed in our engagements. That's stored up in Artifactory as well. Again, we can update these really easily. If we want to pull a new thing from any artifact, we just update the fingerprinting repo, and that's already cloned down. It's already part of the process. One of the last things, project vetting. There's a lot of projects that we use on engagements that we don't control the source code of. This is pretty much the case for anyone in the entire offensive community. So people have different risk tolerances for this, but in general, we try or don't want to just pull in master branches for any code that's pushed up, because we don't want to pull these branches in and changes in without reviewing them to some degree. Because what if somebody with some offensive repo we're using decides to put some kind of subversive logic in, and then we're building this automatically from master, like the master branch of anything, and these things are deployed down to sensitive customer systems, right? We're doing stuff sometimes on domain controllers or with credentials from the keys of the kingdom for a particular environment. So we're trying to be aware of what's the risk of doing this stuff. So we've come up with an update process where we don't audit every single line of every single tool we've ever used. That's pretty much impossible. But we have our offensive toolkit Jenkins file. We have in each one of these files, each project is tagged to a specific public SHA-1 commit. Then every Monday, we have another Jenkins job that clones down everything in the offensive toolkit repo, this internal repo. It checks the commit in the file and compares it to the most recent public commit in the public repository. Then deltas are reported to Slack, and then we manually review and update stuff as appropriately. So like every morning, someone on one of the teams comes in, says, okay, these 5 tools are out of date. They'll review the commits, since the newest commits, since that last week. Check the changes, do a sanity check if the code seems okay. Again, we can't do a full source code audit and review or something like that, but this is better than nothing. Then we update that public commit. into our internal Jenkins file, push it out, and then every new build is going to use that updated bit of that code. Because again, how much do you really trust all these offensive tool developers, right? This is an example of the Slack bot that pops up every Monday morning that I have to deal with, but it'll tell us the particular project, where it is internally, what the public repo is, the current commit that we have for our internal code, whatever the latest commit is for the public code commit dates. So we can just really easily hyperlink, go out, figure out what the new updates are, and kind of do some sanity checks. Again, not perfect, but better than nothing. So wrapping up, definitely consider integrating DevOps practices into your offensive operations if you haven't already. You don't have to do it with our approach using that SCM, Jenkins Artifactory, and kind of some of the sweat. It is a little bit more work. There's not just a run these scripts right out of the box or use the complete public examples. But again, it depends on your risk tolerance. If you're okay using all the AzureDevOps type stuff, please go at it. If you rather do stuff completely in-house, you definitely can do that with Jenkins Artifactory and an SCM repo. But beyond that, no matter how you actually do this, hooking into that tool build and generation deployment process for your engagements allows for some interesting creative applications across operations. Those OPSEC checks, proactive checksum scanning, those types of things. And finally, kind of the current development, what we're looking at going forward. These approaches can also apply for payload generation. So we're converting a lot of our payload generation to like DevOps, essentially, to where there are different repos or different payloads. Some of the things we want to build in are those OPSEC checks, those checksum scannings, but also like things like automatic detonation on like sample systems to see if like all the parts of the C2 and everything all kind of connect up properly. There's a lot more cool things we think we'll be able to do with this, or we hope we can. So thank you. If you have any questions, please ask. I also have a sample declarative Jenkins pipeline via POC or GTFO. It's up there at the bit.ly link. I'm Harmjoy on Twitter and the Bloodhound Slack. And please, if anyone has any questions, please let me know. Thank you.